Alright, hi guys. So today's lesson is about being able to evaluate limits from a graph. So I'm trying out a new setup here at home, so hopefully it all works out and you can see and hear me well. But I'm going to sit down and I'm going to go over this, so hopefully you can see this graph and stuff. We'll figure out this video stuff as time goes on. Okay, so we talked a little bit about instant rate of change and average rate of change before. And really, that's going to tie what you guys were doing when you were finding the instant rate of change was you were evaluating a limit. And let me tell you a little bit more why. So here, let's suppose you have this function. This is x cubed minus 8 over x minus 2. X cannot equal 2. And if you come over here, you can see there's a hole at 2. Okay? So that's a rough sketch. And this table should look familiar because it's almost like we're getting closer and closer to 2, right? So we're evaluating what happens. If we wanted to find the instant rate of change, for example, at 2, we would get closer and closer to 2, making our intervals smaller and smaller and smaller to see what it approaches. So this task wants us to use our calculator, but for the sake of time, I'm just going to show you what we're doing, which you guys should understand this. So if I'm evaluating at 1.75, I'm really just plugging 1.75 into that equation right there. And then when I evaluate that on my calculator, it actually comes out to be 10.5625, okay? And so instead of me working all those out on the calculator, I'm just going to write here what I got when I did this. So this 1.9, it ends up being 11.4100. When you plug in 1.99, it ends up being 11.9401. Here it becomes 11.9940. You can't plug in 2 because that makes the denominator 0, and then it's undefined, right? So this has no value. Then you go past 2, so 2 and 2.001, you get 12.0060, 12.0601, 12.6100, and 13.5625. So here, instead of before when you were finding the rate of change using the slope formula, what we're doing now is not that. We're just plugging in these values to see what is this about, right? So what if we filled in that dot, what would it be if there was not a hole there? So what does it look like it's approaching? From the left side, the function is approaching, it's getting closer and closer to 12, right? Same thing when you look from the right side of the function, it's dropping, decreasing, and getting closer and closer to 12, but not reaching 12. So it should be obvious that as x gets closer and closer to 2, the value of the function becomes closer to 12. It's never 12, but it's getting closer to 12, right? Therefore, what you guys have just found out is that the limit of this function f of x as x approaches 2 is 12. So I'm going to write that bigger underneath here because I know you can't see that. So the limit as x approaches 2 of f of x equals 12. That's what we just figured out. The limit as x approaches 2 of f of x equals 12. And then this is just simply that, but they plugged in the value, the equation for the function. Okay? So this right here says the informal definition of a limit is what is happening to y as x gets closer to a certain number. So what is the output as the input, or the x, gets closer and closer to 2? It seems like it's going to be 12, right? So sometimes the limit doesn't exist. But for the limit to exist, it has to be approaching the same value from the left side as the right side. And you can see here, it doesn't matter if you're coming from the left side of the function or the right side of the function, the value of the function is approaching 12, the y value, right? So the left and right have to be the same side. If it doesn't match, you have a function where the limit does not exist, and we'll talk about that a little bit more. So this is limit notation, right? So what this is saying, so I'm going to make this a little bigger for you. What we wrote here is the limit as x approaches 2 of f of x for that function above is 12, right? But if you want to notate from the left or the right, so if I wrote the limit as x approaches 2 from the left, it is still 12, right? If I look at what the function's approaching from the left, it's still 12 on the graph and the table. So when you use this little negative sign, it means from the left. And the notation for the limit as x approaches 2 from the right of f of x also equals 12. So this is from the right. And then the big takeaway is you can only say that the limit equals 12 when x approaches 2 of f of x if these two are equal to each other. The left and the right are the same. Okay? So let's practice it a little bit more. I'm going to move that down. We're going to look at these two functions here. All right, so here's example 1. They're asking us to evaluate the limit as x approaches negative 1. So as x approaches negative 1. I'm going to see if I can zoom in a little bit more because I see that's hard to see. All right, there we go. So as x approaches negative 1. So we're looking here. Oh, I'm reading that completely wrong. I had to zoom in to see it myself. The limit of f of x as x approaches 1 from the left side. So this is 1, then negatives at the end, so that means from the left side. So I'm just going to write that here, from the left. So if I look at 1, and what does this graph show me the function is approaching as we get closer to 1? It's approaching 1. So my answer there is 1 from the left. Now let's check the right side. What's the limit of this function as x approaches 1 from the right? Coming from the right, at 1, the value of the function is 2. So the left side is 1, the right side is 2. The left and the right side are not equal, right? They're not the same, so therefore the limit at 1 does not exist. This is different from that first example, right? But does f of 1 exist? Yeah, we can evaluate the function at 1. The function at 1 is 2, right? The value of the function at 1 is 2. So that you can have a value there, and the limit can still not exist. Try this one. Okay. What is the limit of this function as x approaches 1 from the left? So from the left, as we approach 1, the function is approaching, let's just call that negative 1. It looks like it's negative 1 point something, but we'll just call it negative 1, right? It's approaching negative 1 because all I'm doing is following the function from the left, and that's what it's getting closer to. What about from the right? 1 from the right. Follow the function from the right, it's getting close to positive 1. Are those two sides equal, the left and the right side? Nope. So that means the function does not exist. Does the function have a value at 1? Yeah, it does. When I go to 1, the only value at 1 is, and when x equals 1 is y equals 0. All right, so I'm going to flip to the next page. We're going to do a couple more. Okay, let's look at this top one, example 3. What's the value of the function when x approaches 1 from the left? From the left, the function is approaching 1. From the right at 1, the function is also approaching 1. So the left side limit and the right-hand side limit match. Therefore, the limit of f of x at x approaches 1 is 1. Now we have to, it's asking us what's the value of the function f of 1. So if I look at 1, when x equals 1, there is no value. So that there isn't 1. Right? That's an error, does not exist. Okay, here, same thing. 1 from the left is still 1. 1 from the right, still 1. Therefore, the value of the limit is 1. And f of 1 is equal to negative 2, right? F of 1 is negative 2. Okay, so if you want to try some of these on your own, then you can pause, try it yourself, see what you get, and see if it matches what I have here. So this one, 0 from the left. 0 from the left is 1. 0 from the right is 1. So therefore the limit from, since both sides are 1, the limit as x approaches 0 of f of x is 1. And f of 0 is also 1, so they all match. Okay, here. The limit as x approaches 2 from the left, sorry. So 2 from the left. Here's 2 coming from the left side. It's just getting bigger and bigger and bigger. It's not approaching a value, right? It doesn't look like it's stopping. So in this case, we would say that it's approaching positive infinity. 2 from the right, same thing, but kind of flipped. It's going down, so the function's approaching negative infinity. There's this asymptote here, right? So therefore, the limit as x approaches 2, it does not exist. Why? These don't match. And secondly, a limit cannot, whenever a limit comes out to be equal to positive or negative infinity, that is the same as does not exist. So I want you to just notice that if a limit of approaches positive or negative infinity, you can write does not exist. So if I put d and e here and d and e here, it would be accurate. What's the value of the function at 2? Also does not exist. If the value of the function of a limit does not approach a number, you can write does not exist. Positive and negative infinity is just so we can understand what's happening. All right, this one. The limit as x approaches 2 from the right, 2, negative 2. As it approaches negative 2 from the right, what's happening? Or from the left. Sorry guys, it's a negative. Let me repeat that whole sentence. The limit of f of x as x approaches negative 2 from the left, negative 2 from the left is positive infinity. Or you can say d and e. Either of those are correct. All right, when we approach negative 2 from the right side, shoop, same thing, positive infinity or d and e. Therefore, the limit as x approaches negative 2 of f of x does not exist. And the value, if we evaluate the function at negative 2, it also does not exist. Okay, here, I want you to try it. Pause, try it, and I'm just going to write the answers here so you can check. It's very similar to the last one. Okay. Okay, so this is what we were talking about. Let's see if it can zoom. There we go. All right, so I'm going to read this to you. It says the concept of limits as x approaches infinity means the following. What happens to y as x gets infinitely large? So this is I'm gonna pause here because we're gonna save this for another lesson, but this is when we're talking about when a limit approaches not a number but positive or negative infinity. So you can look forward to that coming next. And then today's practice is gonna be all around this stuff here, using a graph to evaluate the limit of a function. All right, talk to you later.